Okay, so this video will be a walkthrough of my paper on the computation beyond Turing. So, professor has provided us two papers. The first one is a new golden age of computation architecture, and the other one is the new computation modeling, the new models of computation. So after the a very close reading of the two papers, it provides me a handful of insights from the discussion and the suggestion resulted from the papers. So my paper is basically a restates the discovery from the two provided article and paper. But at this point, I also want to share some my own experience. After that, we will go through the paper again from the beginning. So as a software developer, mostly I spend my time trying to improve the performance of the only on the software side, because I'm not be able to expose to the hardware design, and also I'm not my background is not a solid computer science background, even though I'm now pursuing a master degree in computer science. But the paper, the new golden age of computer architecture, actually gives me a very good a future work that there should be if there is a establishment of a vertical integration that allows software developer and hardware designers to work together to reduce the gap of the work on both sides, to further boost the computer overall performance. I will say I am totally open to that, and I think this is a very great idea, and I really appreciate it, because it will also provide tons of more jobs on this field, and more collaboration means it will just opens more opportunities, opens more ideas, and the entire collaboration will just increase the new technology discovery, and overall create a better human life from a more smarter and much smarter computers. Okay, so all right, so let me to walk through my paper here. So here is my abstract here, the keywords, and then here is my introduction of the paper. So here I mentioned that when I first started this theory of computation class, I barely believe I could survive, but now it's almost the end of the semester. I think that I have learned a lot from this class, definitely, and I think I'm ready to go to the next level of my academic development. Next is the challenges part. I think my paper is divided into four portions. The first portion is challenges, And then the second one is the potential solutions. The third portion is the recap. So there are totally 3 portions to reach my final result/outcome of my discussion. So the first one is the challenges. So in this portion, I gave some example of how the modern computers now, how they take on the tasks to help human being live more easy on a daily basis. For example, like we use computers to calculate numbers. Well, this is the very basic one. We can do it 20 years ago, but now we can use computer to make appointments, place grocery orders. Like you can use the Alexa to play music while you're cooking in the kitchen. You can use Grammarly to check your Grammarly usage while you're writing the documents, or you can send emails. You can send emails on a preset time, and you can also use computer as a storage to store tons of pictures, videos. So this general daily tasks is a general computer or smart devices can take on. And I mentioned here a dishwasher, a refrigerator is much smarter than before. Like a Samsung refrigerator can track the refreshness of the vegetables and fruits stored in the refrigerator, and the dishwasher can connect to your home Wi-Fi to tell you whether it's completed or not, like the status of the current dish procedures. And yeah, so there are more that our human being will rely on a modern general computer, but there still are challenges we are facing. So the core challenge is that all the tasks stated above rely on the one traditional computational model, which is the Turing machine model. The characteristics is that it takes in a finite inputs, knowing the finite inputs and a well-defined steps in advance. But these 2 characteristics will not allow a Turing machine model to be able to solve a undecidable problem. So there are areas a traditional machine cannot handle well. So for additional examples, as stated in the paper New Models of Computation, that in the paper it says that the dynamic interaction of clients and servers on the internet, that is a one specific case that a traditional Turing machine cannot solve well. The challenges right now that current modern computers are facing is the problems of open systems, the needs of an evolution, and the infinity number of available resources. So in addition to the developing of the computation part, the theory part, we are also facing the architecture limits of hardware evolution. So as stated in this a new golden age of computer architecture paper, it has described the 30 years of computer hardware architecture design evolution history, and it gave us a overall picture of how computer has evolved from 1980s But entering into the 2020s, we are facing the limitations of a hardware design can barely improve the performance very well in the needs of energy efficiency, such as in a mobile device, or the limitations of a security breach, such as the cloud computing and the performance gap that the deep pipeline of a CPU design or the memory management status of current hardware cannot efficiently improve the performance anymore. So we need something else to help us. So the second part is the potential solutions here. Basically, I restated all the solutions that have been described or discussed in the two provided papers. So for this, the new model of computation, it suggested three different new models, which is the interaction machines, the pi calculus, and the cost calculus. Even though these three new models are not the only three that has been explored, but this paper still gave us a more detailed description of how a new model can help solve the problems that a traditional Turing machine cannot solve. And for the architecture part, this paper introduces a very interesting idea that it says to introduce a vertical integration of a computer architecture design and a programming compiler design that use the software program to take control of the caching or memory management that will help boost the performance. And for introduce that, saying that the idea of a domain-specific architectures that instead of investing a more general architectures, we should design more domain-specific, a combination of software and hardware to solve domain-specific problems. And the agile hardware development suggestion, which it could gracefully and largely reduce the performance gap as being described and discussed in the paper. Yes, the domain-specific architectures and the agile hardware development both will boost the overall development of our current computer architecture that the current modern computer are evolving from. So the final portion is a recap. So the recap here, I put a restate of the challenges and solutions. In this paragraph, I said that the traditional Turing machine will no longer be able to evolve from a more and more challengeable environments. We need a more robust system that allow us to rely on to allow us to do more complex computations. That the heavy hardware design will be offloaded and a more software design effort will be put into the language compilers and software stack that could take control the memory management to boost overall computer performance. And the super Turing machine model will be continuously being explored and studied to better modeling on a domain-specific system. So so overall, my opinion on these two papers is that I totally agree with the discussion points that these two papers has provided. My idea is that these two the opinions that these two papers has provided could be could be combined together. There are no conflicts between them at all. So if we can have a domain specific a open architecture to be set up, if we have a platform that allows more developers, including hardware developers and software developers, to contribute together, and at the same time, meanwhile, if we have more a super Turing machine model to be explored that we can use to allow us to write more robust software application, then a combination of these two developments will basically will definitely boost the computer performance and will largely allow a current modern computer to pick up tasks that could taking infinite inputs and generate infinite outputs and can evolve by themselves.